Hi, IB. We're going to focus on A3 solving algebraically. So everything we do is now going to link what we've been doing the last 2 days visually, graphically, using your calculators, being given a graph. A lot of the questions you guys had, you were graphing sine or cosine, and then you were finding when sine or cosine intersected with some value. And so we set them as two separate functions and looked for the intersection points. And that was all done visually. However, today this is all going to focus algebraically. So our first step, as we introduced in our last video, was isolate the trig ratio. And this time, you might need to also change the interval if you're not just given x as your input. And we'll look at an example where that happens. However, this one, our trig ratio is already isolated, and our interval does not need to be changed. So we've done that one. Identify your reference angle. So if I'm going to take inverse cosine and isolate x, I'm looking at inverse cosine of -1/2. So I'm going to write myself a little bit of side work before I write down my answers. So my side work is going to be, well, if I think about what triangle I need to use here, so this is our 30, 60, 90 triangle. So across from 30 degrees is 1, we've got root 3 and 2. And let's see, for cosine, to have an adjacent side of 1 and hypotenuse of 2, I'll be standing in that 60-degree corner. So we have a 60-degree reference angle. And for it to be negative, I need to be thinking in quadrants 2 and 3 for cosine. All right, so some side work is just that thinking process. I'm using my 30, 60, 90 triangle, reference angle of 60 degrees, and I'm in the second and third quadrant. So now that I start to isolate x, I write down what values would satisfy this equation. So when I'm between 0 and 720s, 60 degrees in quadrant 2 would be 120 degrees and 240 degrees in quadrant 3. So I have two answers already, and those two answers, though, only satisfy my interval from 0 to 360, so to 2 pi. Right? So now that I'm actually needing to extend that interval to 720, I'm going to go around the circle a second time. So it's almost as if my graph were just going to continue. So that's what we were looking at the other day. Again, this is just an example up here. So if my graph continues, I'm going to go around the circle a second time. So I'm going to add 360 degrees, and therefore I would get 480. And I would also get 600. So notice that, let's switch to red. If I go from 120 to 480, I've just added 360 degrees, which means I've traveled around my circle a second time. 240 to 600, again, I've added 360 degrees, and that's traveling around from these original 2 points, or two angles, and an additional circle, 360 degrees later, I hit again at 480 and 600 degrees. All right, so now I have found the correct values within the interval I was given, and I've completed my question. So this second example gets a little bit more interesting. When I'm asked to isolate the trig ratio, it is not already isolated. So I do have to subtract 3, and I do have to divide by 3 as well. So if I just subtract 3, I'm looking at 3 cosine 2x is equal to -3. And then divide by this coefficient of 3, so cosine of 2x is equal to -1. So I have isolated my trig ratio. All right, now I need to look at my interval. I am no longer just asking for cosine of 2x. So if I use inverse cosine, I'm actually going to be isolating 2x instead of just x. So what I need to be thinking about is I'm basically doubling this x value. So if I double x, think about how inequalities work and keeping everything balanced. If I double x, I also need to double 0, which would just be 0. And I also need to double 3 pi, which would now be 6 pi. So instead of finding solutions only between 0 and 3 pi, because I have a double angle, I need to find my solutions between double the distance, which is 6 pi. All right. So now I need to, again, go through my same steps. Find my reference angle. So for cosine to be -1, I'm talking about pi. So cosine is -1 at pi, and this only occurs once in one full revolution. So I am looking at, and it's not a triangle this time, well, my triangle has basically collapsed on itself here. So when I'm going to the left 1 unit on my 1 unit circle, I have a x value or cosine value of -1, so that happens at pi radians. So find the two values. Well, for this one I won't have 2, I'll just have 1. That happens at pi. And now I need to think, well, when else would this happen? All the way up to 6 pi. So again, I'm going to keep this 2x for a moment. Inverse cosine at -1 occurs at pi. And then if I go around the circle a second time, I'm going to travel an additional 2 pi. So that will happen again at 3 pi. And then if I go another 2 pi radians around, I'll wind up getting 5 pi. And if I go another circle, I'm going to pass 6 pi. So I'm going to stop there. I'm almost done. So again, I want to notice before I move on that what I've just done is I've added 2 pi, and then I've added another 2 pi. All right, so just notice what we've done there to get our other values in the interval that we're being asked to find. So coming back to our question, if I want to now solve for x, I'm going to divide everything by 2, which means I also divide all of my solutions by 2. So my final answer is going to wind up being x equals, and I've got 3 answers, pi over 2, 3 pi over 2, and 5 pi over 2. All right. Now, one way that we've talked about checking our work, let's think about what we did just last class with graphing. Let's graph 3 cosine 2x plus 3 as one function, and then let's graph 0. So we're looking at basically solutions, or when this graph will hit the x-axis. So visually, just to check my work, I've graphed 3 cosine 2x plus 3 in blue, and then y equals 0 is in red, and I notice I have 3 solutions. So this first one is pi over 2, the second one happens at 3 pi over 2, and then 5 pi over 2. So there are my 3 intersection points, and it just helps to reinforce that I did do my math correctly, algebraically. All right, for a third example, again, we have to do a little bit of work before we can begin. And the first step, again, is to isolate the trig ratio. So I'm going to wind up keeping cosine of x minus 3 pi divided by 4, and I'm going to subtract 1 and divide by square root of 2. I also need to look at my interval because I do not just have cosine of x. My angle is affected by the -3 pi over 4, so I'm actually moving right 3 pi over 4. So if I'm going to subtract 3 pi over 4 from x, I also need to subtract 3 pi over 4 from 2 pi. So let's think of 2 pi as 8 pi over 4. So if I subtract 3 pi over 4, I'm going to have 5 pi over 4. And if I subtract 3 pi over 4 from 0, I'll just have -3 pi over 4. So my window does change slightly, and that just helps to make sure I don't miss any values of theta that I need, or any angles that I need. Again, if I inverse cosine, I'll wind up with x minus 3 pi over 4 is isolated now, and inverse cosine of -1 over square root of 2. I'm trying to think back to the triangles that I need to use. So the one triangle I need for this one is my 45-degree reference angle. Adjacent for cosine would be 1, hypotenuse would be 2, and it's negative. So I have a 45-degree reference angle, or pi over 4, and I'll be in quadrants again, 2 and 3 for cosine. All right, so the two values that would satisfy this equation just between 0 and 2 pi, I'd be looking at our 3 pi, let's see, yep, 3 pi over 4, and 5 pi over 4. We have to make sure to keep x minus 3 pi over 4 is equal to, all right, so 3 pi over 4 is one solution. 5 pi over 4 is another one. And if I travel around my circle one more time, so if I add 2 pi units, if I add 8 pi over 4, so that's 2 pi, I'm going to go beyond the interval. So this is asking me to stop at 5 pi over 4. All right, and I can be equal to 5 pi over 4 because we have equal to here, less than or equal to. So 5 pi over 4 is included. So now let's try to go to the left. So if I subtract 2 pi, where would I wind up? All right, so if I wind up subtracting 2 pi, I will be able to include negative 3 pi over 4. So we've got negative 3 pi over 4, because if we start at 5 pi over 4 and subtract 2 pi, 8 pi over 4, we'll get negative 3 pi over 4. Now, if you think visually about this, 3 pi over 4 is in the second quadrant. 5 pi over 4 is in the third quadrant. This is if we're starting at 0 and we're moving in a counterclockwise direction. However, since we are now including all values to negative 3 pi over 4, this would be moving the opposite direction. So now that I count by units of pi over 4, here's negative 1 pi over 4. And negative 2 pi over 4 would be at negative pi over 2. All right, and then here we'd have negative 3 pi over 4. So negative 3 pi over 4 moving in a negative direction is equivalent to moving in the positive direction to 5 pi over 4. All right, so 5 pi over 4 and negative 3 pi over 4 are representing the same, kind of the same reference angle in the third quadrant for cosine. All right. So now that we have our 3 possible solutions, we are going to finally isolate x. So we can't forget that we have x minus 3 pi over 4, as it was given to us in the question, is equal to these 3 values. So my last step is to add 3 pi over 4 to all of my solutions so that I can isolate x. So 3 pi over 4 plus 3 pi over 4, I'll get 6 pi over 4. 5 pi over 4 plus 3 pi over 4, I have 8 pi over 4. And then negative 3 pi over 4 plus 3 pi over 4, I actually get 0. So let's always simplify. X is equal to 3 pi over 2, 2 pi, and 0. So those are my final 3 solutions, and they all are within my original interval, because now we're talking about x. So x has to be between 0 and 2 pi. And these x values are between 0 and 2 pi, all right? So we were using this alternate interval because we had to shift with the 3 pi over 4. So we just want to shift and use that to find our solution so that we don't miss any possible solutions, because now we're not just going to have our 2 from 0 to 2 pi necessarily. We might have more than that. All right, guys, this example 4 we're actually going to do together in class tomorrow, but I will start it, give you guys a hint. We're supposed to isolate our trig ratio, all right? However, I see 2 trig functions here. We've got sine x equals square root of 3 times cosine of x. Well, what I do know is I could put sine and cosine together some way to make another trig ratio. So if I actually can rewrite this, maybe think of how we divide by cosine x. I can change this question to tangent equals root 3. All right, so always be thinking, how can I simplify this question so that if it follows these same 4 steps and it gets to a point that I can actually handle it. All right, guys, try this one on your own. We'll see you guys later. Good night.